Today we are going to see one application of k-mean clustering. Means in the k-mean clustering, how can you use k-mean clustering? We are going to do a mini project image compression using k-mean clustering. So first of all, what is the image compression? Okay, and we will see how we can use k-means algorithm to implement the image compression. Okay, like we have millions of images, we are uploading millions of images every day over the social media sites. So what we need a image compression technique. Hello everyone, this is Sharda from GoEduHub Technologies and I would like to welcome you again for the session Machine Learning with Python. Can you please confirm me in the chat window, am I audible, clear and loud, so that we can start the session. Okay, and after a week we are going to do one task today, like one of the good application of k-mean clustering. In the last classes, we have studied what is the k-mean clustering. We have studied what is the unsupervised machine learning. So I don't need to repeat that things. Now the thing is, what is the image compression and why we need it? Okay? Like how our computer is storing the images. We have colored images. Okay? And colored images are basically stored in the form of pixels. Like we have an image like this. This is an image of certain scene. Okay, and what the computer understand, computer basically having an array of certain values like 10, 20, 30, 255 and 40. Some values it will have 0, 55, something like this. So basically these values are dots. They represent pixels. Okay? And colored, these pixels basically intensity of the image. Okay? And one more parameter we are having, that is the color. So in a colored image, each pixel, like this is a pixel, and this pixel having combination of 3 colors RGB, red, green and blue. Okay, so every pixel having certain intensity of red color, certain intensity of blue color and certain intensity of green color. Other colors are combination of red, green and blue. So basically if your point is totally red, it means red pixel value is 255 and other green and blue is 00. Okay, and similarly if it is a mixer color, then it depends on which color is more dominating. Okay, so basically color image have huge size. Okay, nowadays you are having DSLRs, you are clicking images whenever you are visiting certain cities and certain good places. Okay, but what happens, it will take lots of space. So these images are basically stored as a compressed images with lesser number of bits for the intensity value, and so that it will take the less memory for the storage. So you can say this image compression is a technique of data compression. I just want to change the color. So I can say this image compression is a technique of data compression. Okay, and data compression is basically applied to the digital images to reduce their cost of storage and transmission. Okay, so what we can do here, like over the WhatsApp you are sharing the images with your friends. What WhatsApp does, it reduces the quality. You know that How it reduces the quality? It basically compresses the images. When you are uploading images, some social media networks, they are also reducing the quality. Okay? So here we are going to use k-mean clustering technique to reduce or to do the data compression for an image. How we can perform k-mean clustering for the image compression? Okay? So for the image compression, what we will do, we will apply k-mean clustering. It is a algorithm. It is a algorithm of unsupervised machine learning. Okay? So how we will apply k-means? I'll explain you. Here we will take certain k centroids. Or you can say k clusters. So data points, we will cluster the data points together on the basis of similarities. Data points on the basis of similarities. Initially, we will start with a random number. Random k we will pick. And then on the basis of similarity. Okay? We minimize the distance from every data points to the cluster center. Okay? So each data point will assign a cluster. Whose center is nearest. Okay? And then what we will do in the next step, we will update. Like we are doing in the k-mean clustering, we will update new cluster centers. Don't worry, I will do the implementation part so you will get the more clarity. Cluster centers. Okay? And this iterative process we will apply until our centroid stop moving. Okay? So here we will pick an image. We will pick a random image and we pick initially original image and then we will compress the image. Like we can compress the image in the 64 clusters, we can compress image in the 2 clusters, or we can compress the image in 128 clusters. Okay? Are you getting the things? What is the basically problem statement? Today we are going to do the image compression using k-mean clustering, or this is a mini project. You can say we are going to implement a mini project in which we will minimize color. Okay, so we compress the image, data compression technique. This is called data compression technique. Okay, so let me do the practical part. I will start how to do the execution. Okay. First of all, we will download a random image. I'm taking an image of peacock so that I can see the colors very carefully. Okay, so I'm saving this image at my desktop. Peacocks 01. Okay. Now I'll open Google Colab, and in the Google Colab, I'll start the execution. Okay. See, the k-mean algorithm we already know. This is the application of k-mean algorithm. Okay? So what we can do? Initially, we will import data science libraries. You know, we need to process this image. So here, import data science libraries. Okay? And first of all, I'll import Numpy. Basically, image is collection. You can say image is a Numpy array in the system. It's a stored as a Numpy array. So I'm using Numpy, and then I'm using pandas spd, and then I'm importing matplotlib because I just want to plot the image. Matplotlib dot pyplot as plt. Okay, and from the sklearn I'll import k-means. Sklearn dot cluster import k-means. Okay, let me run this block. All the necessary libraries I have imported. Next thing is I'll read the image. How can I read an image? I can read an image with the help of matplotlib library, or I can read an image with the help of CV2 library. So right now you don't know the CV2, so we are going to use here matplotlib to read an image. Okay, so first of all I'll upload an image here in the Google Colab. And over the desktop, I have Peacock01. Okay, so I'm uploading this image here. Peacock01.jpg. You guys also do along with me. Now I'll read the image. img equals to plt dot, there is a function called imread, and then inside the braces I need to write the name of the image. So it is the peacock01.jpg. I think this would be the name. Okay, and then I'll check image plt.imshow, and inside the imshow I need to write the name of the variable img. Okay, and then plt.axis off. I don't want to show the axis. Okay, and then I need to write plt.show. Let me run this code. No file. Okay, it's a file name. Let me check it. Peacocks01. It's not peacock. Okay, now we will run again. And you can see this is the image. Okay, and I just want to store this image with reduced data. Okay, guys, clear the concept what we are going to do today. Yes, we can do the video also, but first just read the image. Video is nothing. Video is a collection of images. So what we can do? We can read the video in the form of images, multiple images. So same operation, we need to put that in a loop. Okay? Okay, guys? Now the next thing is what I can do. I need to check out this image, type of this image. And then I'll check out its data, like it's a Numpy array and how pixels are stored inside the system, and then I'll implement k-mean clustering. Okay? So type of img. And this is a Numpy array, you can check. And then I can check shape of this array, img.shape. And this array having rows, columns, and third thing is color component 3. 3 is basically combination of red, green, and blue. Okay, img. You can see this img is an array and having pixel values. Okay, and these pixel values are the intensity of an image. Now you can understand how an image is stored inside a system. Images is stored inside a system in the form of Numpy array. Okay? Now we will normalize this image. Like these pixel values are in between 0 to 255. So img equals to img divided by 255. Okay? And now you can see the img. Okay, Ajay is writing, ma'am, please take up the ML and DSA classes in weekdays, make leaves on weekends since the weekly 2 classes will extend 45 days to 3 to 4 months, so kindly consider it. Okay, Suraj has also written weekdays. Okay, we will try. Actually, there was the request from certain students, that's why we made this a weekend batch. Okay, we will think about it. And I will try to complete this course within a month because 45 days is more and it will be the more long. So I'll try to complete the course in a month, like 30 days. Okay. So let me talk to the management and then we will consider it. Okay. So first of all, what we have done here, we read an image and then we see how images is stored. Images is stored in the form of Numpy array and shape of the image is 670 into 1024 into 3. And image is basically these array values. And then we normalize this image. Okay. Why 255? Actually, image pixel value is in between 0 to 255. So 255 is maximum value. So if I'll divide all the pixels with the 255, then our values fall under the range of 0 to 1. And in the machine learnings, basically, values in between 0 to 1 is best suitable to train a model. Okay. Suchita, you can check out now all the assignment links are available. You can check out our Facebook and LinkedIn pages. Last 2 classes assignments also available there. You will complete those assignments. Actually, there were certain things I was not there in the last week. So I have not provided the assignment for the last week. Today we have completed all the last week assignments. Okay, so you guys go through that there and then complete. So now we have data in the form of an array and that array having certain values in between range of 0 to 1. And this is a 3D image. Okay. So we need to convert this 3D image to a 2D image by combining W and H. Okay. So 3D to 2D image by combining W and H. Okay. So here we will write W, H and D equals to my image shape. Actually, I am storing my image shape inside three variables W, H and D. You know image shape? Okay. And then we can write image underscore array. We can take another new array equals to, we will reshape our image from 3D to 2D. Okay. Till now, if you have any question in between, you can ask me. Okay. Reshape. We know how reshape works. Actually, we used in the Numpy. So W into H, comma D. Okay. And now you can check the new shape of our array. So image underscore array dot shape. And you can see the shape is W into H into D. It's a 686080 into 3. Yeah, Suraj, I'll check your task over the LinkedIn surely. Okay, are you getting the things till now? Can you please confirm me in the chat window? It's look like people are not taking the interest. Okay, it's a very nice project. You can do this, and you know already K-mean clustering, so you can easily complete this task. You know basics about the Numpy array, you know basics about the matplotlib, you know basics about the pandas. Okay. Now what we can do? Now we have our data in a form of 2D array. Okay. Now we will import sklearn. We will use sklearn library. And we shuffle our data. Okay. So from sklearn dot utils import shuffle. Okay. Sorry. And then what I can do, I don't want to apply our model to complete data. I'll pick some 1000 pixels only. I don't want to work over as much pixels. Okay. I'll pick a small subset from this complete image. Okay. So here what I am going to do, fitting model on, you can say on a small subsample of the complete image. Okay. So I can write image underscore array underscore sample equals to, randomly I am picking 1000 pixels. So shuffle function here I am using. Shuffle image underscore array. Okay. And here I am taking the random underscore state equals to 1. And then inside the square bracket I am putting 1000. First 1000 pixels I am picking from the image array and then shuffling those pixels. Okay. Image underscore array underscore sample. This is our data set. And you can check out the size. Size is 3000. Okay. Because our data is 686080 into 3. So we are picking 1000 into 3. Okay. This is the data set I'm going to train our model. I'm going to fit into our model. Now, here, I'll take k-means equals to k-means. Okay? K-means algorithm I'm taking. And number of clusters I need to specify here. Number of clusters equals to. Okay? I can give here any value. Okay? Like I just want to give here 10. And then I'm providing here random street equals to 1. And then this is my model. K-means is my model. Okay? And inside this k-means, I'll fit my data. K-means dot fit image underscore array underscore sample. Okay? This is my data set. Image underscore array underscore sample. I'll fit to my algorithm k-means. Got it? Somebody is asking, repeat the function from utils. Inside the sklearn, there is a package called utils, and inside the utils, we have function called shuffle. So shuffle basically what it does, it will, like you have certain data. You have 1000 pixels. You just want to shuffle. You don't want to keep them in a particular order. You just want to shuffle the data randomly. Okay, so it will shuffle your data. So this is my model I have created. Next thing is we will see the labels, or you can say get the labels all the centroid on complete image. Like what we want to do, we want to make total complete 1000 pixels. We will divide 1000 pixels into 10 clusters. So what we will do, we will assign a cluster number to every pixel value. So like first pixel is assigned to cluster number 1, second pixel is assigned to cluster number 3. Like this, we will assign a label between 0 to 9 for all 3000 pixels. So what we can see here, labels equals to k-means dot predict. Okay? And then we can write image underscore array. Okay? We will get all the labels. I can write here the comment. Get labels all centroid on the complete image. Complete image means here I am taking the image underscore array. I have trained my model with the image underscore array underscore sample. Now I am predicting label for the complete image. You can print the labels. Labels is a big array. And every pixel is assigned a label between 0 to 9. Okay, you can see label for a first pixel. Suppose I just want to see label for the first pixel. So how can I say label oblique 0? This is label for first pixel. So means my first pixels falls under the cluster fifth cluster. Okay, and now I'll print cluster centers. K means dot cluster underscore centers. Okay, how much centers? 10 centers. Actually, we have divided into 10 clusters. So we are getting 10 centers. These are the 10 center points. Okay. Now these centers I'm assigning to a variable. Like I'm putting inside a variable called C. So K means dot cluster underscore centers. So cluster centers I'm putting inside a variable called C. Okay. Nothing new. And labels, you can see label size, like labels. Label size is total image size. We have labels for complete image. Here we have predicted the labels for complete image. And these 10 centers we are having. Now next thing is we just want to recreate the image according to the labels. Like we are having original image and now we just want to recreate the image according to the data compression. Like in our image, we are going to keep only the 10 labels. So this is the important part. Okay. So here, recreate original image according to labels and each pixel. Okay, we just want to recreate our image. We know our original image and we want what is the image after the compression, how our image looks like after the compression. Okay, so here I'll define a function def recreate. Okay, recreate underscore image. And this is very important function, guys. Just look at it carefully. Here I'm going to use certain logic. I'm passing certain parameters like C is centers and then I'm passing labels. Okay. Then I'm passing the size of the original image W, H and D. I just want to create an image of size WHD with the center C and with the labels. Okay. Here, what I can write, image equals to. Initially, I'll declare an image of zeros. So I can write here np.zeros. And inside this zeros image, the size of the image I'm keeping W into H into D. So this would be my final image. Image would be my final image, size of W, H and D. Okay. And here I'm putting a variable called label underscore idx equals to 0. Label ID I'm putting here 0. Initially my label ID is 0. Now what I will do, now label each pixels according to the limited labels. Okay, like for each pixel we will assign a label in between 0 to 9. Okay, so what we can write here a loop for I in range W. Okay, and then this is my width. Okay, then I'll run again one more loop for J in range H. Okay, this is the size W into H, and third parameter D is a color. Okay, so I need to create an image of size W into H, and for every pixel we need to put certain label. So here image of I and then J. What we will put? We will put a label. Like labels. Okay. And inside the labels we will put a label ID. Labels underscore IDX. And label ID we are incrementing by 1. Labels underscore IDX equals to okay. So suppose initially label ID is 0. You can print this label ID so that you will imagine clearly. Print label underscore IDX. This label IDX is basically incrementing by 1. Okay, initially it is 0, then 1, 2, 3, 4, 5, 6. It will go till the W into H. And this labels array we have. This labels array size is basically 686080. So from this labels array, we are putting this index. Inside this labels array, we are putting index labels IDX. Okay, so initially its value is 0, so we will assign labels 0. So value at labels 0 will be assigned to image I of J. Value at labels 1 will be assigned at image I of J. Okay, like this we are assigning the label value to the image value, image pixel value. So label value is, what are the label value? Actually, this will give you the output in between 0 to 9 only. You can print this also. Okay, let me run this. Okay, for running this, we need to pass here, we need to call this function. Okay, recreate underscore image. And inside the braces, I'm passing C, and then I'm passing labels. Okay, and then I'm passing W into H into D. Let me run this. What happened? Cannot interpret 1024 as data type. Okay, let me correct. np.zeros, and we need to put this W into H into D inside a bracket. Now this will run. One more error. Local variable labels underscore IDX referenced before assignment. Okay. There are certain errors, I need to correct it. Okay, here I have put it label underscore IDX, and here I have used labels. So I'll correct it. I'll correct it here. Labels underscore idx. Or it's label underscore idx. That's good. Label underscore idx and then label underscore idx. Okay? Or this is labels. Let me run it again. Hopefully now it will work. Yes, you are getting certain values. And it's very big. Like this thing. This thing is basically label idx. And the second, like somewhere you are saying 2074. These values are basically label at this particular index. So it will run till the 686. Some value size is 686080 times. So we are assigning label to image. Okay, I'm stopping this. It will take some time. Are you getting the things? What I am trying to tell you? Basically, we just want to recreate an image. Okay, and we just want to assign the certain labels to the image. And not only the certain labels, now I'll change it, in place of labels, I'll change it here centroids. So I'll write here this labels, I'll pass to the C. Value of that particular centroid. Like here, this is 0 or this is 2. 2 means the centroid value at second label. Okay, C of 2. C of 2 means centroid value at second. These are my centers. So centroid value at second is this. So we will assign this value to our pixel. Okay? I need to stop it out. Now I have changed it. In place of labels index, and I put it one more thing is C of labels index. Okay. Now I don't need to print out. I'll commenting these things. Print is only for our understanding. So I defined this function. And now what I can do, I can return this image. Okay. Outside these both loops, I'll return image. Okay. This is the function I need to define to recreate an image after applying the clustering algorithm. Okay. Now let me see the difference between the original image and recreated image. So let me plot plt.figure. Okay, first figure I'll put original image. Okay, we know the original image. plt.axis is off. And then I'm writing here plt.title original image. Okay, and plt.imshow what? Original image variable, I think img. Okay, and then plt.show. Let me show. This is my original image. Now I'll create second figure for reduced image for new recreated image. Okay. So I can write here plt.figure 2. Okay. And then I can write here plt.access off. Okay. And then plt.title is reduced. And now plt.imshow, and how we can create the image? We can call recreate image function. Okay, so here I'll call the recreate function. Recreate underscore image. And inside this brace is what we need to pass. We need to pass C, we need to pass labels, and we need to pass W, H, and D. Okay, and after this we will show image plt.show. Now you can see the difference. Regional image, I can reduce less clusters, like in place of 10 I'm putting here only 2. Okay, let me run this again. So you can see the clear difference. This is my original image and then the reduced image having only 2 clusters. It is look like only the black and white image. So we have reduced the image. You can adjust the number of clusters according to your need. Like you can put the number of clusters 2, 3, whatever you want. So each cluster centroid. Here each cluster centroid is representation of 3-dimensional colors in the form of RGB colors. So we have applied k-means algorithm on the pixel values to get the resultant compressed image. And what we have done, we basically replaced the pixel value with the value of cluster centroid. So what we need only to store the labels for each pixel, and that will tell you the cluster to which that pixel is belonging. Okay, so we are here keeping the record of color vectors of each cluster center, and you can see here the difference clearly. Obviously, this compression is lossy compression. Image may be vanished after this compression. But as soon as you are increasing the value of k, it will minimize the loss. Like when I decreasing the value of k, it means maximum loss. Okay? Are you getting the things? What I have done, I can change the number of k according to my need. And we are compressing the image, and this technique, like we only reduce the number of colors here. Okay? We reduce the number of colors to represent a colored image. This technique is known as color quantization. There can be different ways to achieve this task. This is one of the way that we used with the help of Python using the k-means clustering algorithm. You can implement k-means algorithm with the help of MATLAB also. Okay? And you can use some other algorithms also. But this is one of the way to reduce the colors in an image. And you can recreate an image like this. Okay? If you have any question regarding to this, you can ask me now. The important thing here is recreating the original image according to the labels and each pixels. Because this is the little bit complicated, you have to understand this clearly. What we are doing here, we are recreating our image. We have taken an image and then from that image we have taken only the sample image to train our k-means algorithm. Then with the help of this trained model, we have predicted labels for the complete image. And those labels, the centroid value for those labels we are putting into the new created image. A new created image size would be the same size as we are having in the original image. So this is one of the application of k-means algorithm. Okay, clear till now? We can go ahead. Yes, we can create more brighter. Okay, you just want to enhance the quality of the image. No, you cannot enhance the using this technique, k-means. Like actually we have limited colors. We are storing certain colors, we can reduce those colors. For enhancing, we need certain different things. With the help of this algorithm, you cannot enhance. Okay, Kiraj? Now I'll tell you one more important library. There are the lots of things in the Python. If you explore the things, then you will get the different thing, very interesting things. Suraj, I cannot take the example of video. Actually, when you are working with the videos, you need to work with the OpenCV. And that is, you don't know till now, so I cannot take the example of video. Because with the help of Matplotlib, I can handle the image. Handling the video is a little bit complicated. For that, we need to know the little more things. So right now, you are not up to level to understand the things. You need to study more things. And I have one course on the OpenCV over the Udemy. You guys can take that course. You can study. There are the lots of things are covered in that course. I can give you the link. This is the course. We will provide the coupon code also. So you will get a certain discount. Obviously, Udemy have very less cost. So it is not like it may be around $10 or something. Or if it is possible, then we will give you some coupon codes also. If you guys want to attend, you can attend this course. And totally this course is dependent on the images and videos. First, you go through the content and then let me know if you want certain coupons, then we will give you. Okay? Now come to the one more thing. I'll tell you some good libraries in the Python. One is GTTS. Okay, what is the GTTS? It's basically you just want to convert text to speech in the Python. Then you can use GTTS. Like I can tell you, we completed this project today and we are having certain time now. So I'll tell you two more interesting things. Okay. Convert text to speech. There are lots of libraries available in the Python. If you explore it, it is very interesting language. And you don't need to write lots of code. It's very simple. Google text to speech conversion. Okay. Here I'll import the library from GTTS. I'll import GTTS. Yes, I think this one is the library. Okay, I need to install the package first. Okay, so pip install whatever. If you don't have any package, you need to install that package over the Google Colab. So pip install GTTS. You can telegram to our office number, that is the 7976731765 for the coupon code, so that the day people can provide you the coupon code. Okay, I don't have access for the coupon code and all these things. Pip install GTTS. Okay, I have installed this library and now what I can do, I can convert from text to speech. Okay, so here text which I need to convert into audio. Okay, like my text, I just want to put here my text equals to welcome to GoEdu Hub. Okay, and language in which I want to convert, I need to specify the language. Okay, so here I am specifying the language is English. Okay, and then I am putting here GTTS okay, and inside the GTTS I am passing text. So text equals to this variable is my text, and then here I need to pass the lang equals to this language. Okay, and you can say slow or fast, so slow equals to false. Okay, now I can run this. What? GTTS is not defined. I have defined the GTTS. Okay, after the installation, I need to import once more. From GTTS, import the capital TS. Okay, now this is imported and installed, And text I have taken welcome to GoEdu Hub, language I have taken English, and then I am passing this text to GTTS. Okay, and this is converted to audio. Okay, now I can save this audio like my dot save, and then I can put here GoEdu Hub .mp3. Okay, this will save a mp3 file. You can see here goeduhub.mp3, and you can play this file in any mp3 player. Like I'm playing in VLC media player. You can listen in your system. It will tell you welcome to GoEdu Hub. Similar thing, if I just want to write in the Hindi, then I need to put the text into the Hindi, like my text equals to some Hindi text. And then language I need to pick Hindi HI. For the English we are using EN, and for the Hindi we are using HI. So you can convert text into Hindi and into like English. I can play this mp3 file here also. Like I just want to play the mp3 file in Google Colab. Then I can write here the code, like I can use the IPython. So the path equals to goeduhub.mp3. This is my file. Okay, and then I can import IPython. IPython.display. Okay, and then I can write IPython dot display dot audio. There is a function called audio, and inside the audio I need to pass the path, and then it will play this here, and you can listen in your system. Okay, so like this you can use this GTTS library. Okay guys, I think this is enough for today. We have seen one mini project, that is the image compression using k-means algorithm, and then we have seen one library, that is the GTTS. Okay, Rohit has written, ma'am, due to the semester exam we are unable to take classes. Semester exam will take I think 1 week or 2 weeks. After this you can miss 1-2 classes, and after the semester exam you can revise the classes. Okay. Yes, Giraj. Giraj is asking a question. Can you please directly play without downloading? Yes, I have done that thing. Okay, got it? I can play directly here. There are the lots of things available inside the Python. I can say it is the simplest language on the earth. You can easily learn this language. But before the learning the new libraries, you should clear the concepts. Because if you don't clear the concept and you are just picking the new things, you never crack the good questions. Like if you are going to sit in a good company interview and they are giving you certain conceptual questions, they never ask you for a particular language, you can solve this question in a particular language. Okay, but the thing is, you know the concepts. Okay, and guys, please hit the thumbs up button so that I can know you guys are getting the things. Okay, Okay, thank you so much. We'll see you in the next class. Good night. And don't forget to complete your assignments.